Next, based on the number of reactant species undergoing oxidation and reduction, we can divide the redox reactions into two types. Normal redox reactions. Oh, okay. Based on the nature of the reactant species that are undergoing oxidation reduction, we can divide the redox reactions into two types. Normal redox reactions next, abnormal redox reactions. Abnormal redox reactions. Next, in the normal redox reactions, if one species undergoes oxidation, the other species will undergo reduction. That means two different species are exchanging the electrons. Just like, say for example, if A and B react with each other, A will convert into A plus and B will convert into B minus. That means here A is losing the electrons, B is gaining the electrons. That means here two different species are exchanging the electrons. Hence, it is a redox reaction. But since different species are exchanging, hence it is called normal redox reaction. Next, the example for this normal redox reaction is zinc. When zinc react with the copper sulfate, ఏమైంది ఆన్ చేయలేదు మీరు ఓకే ఓకే మళ్ళీ రాయాలన్నా తుడిపేసి ఈ కింద ఇవి తుడిపేసి మళ్ళీ రాయాలనా ఏం వాయిస్ రాలేదా based on the nature of the species that participates in the exchange of electrons, the redox reactions are divided into two types. First type, normal redox reactions. Normal redox reactions. Second type, abnormal redox reactions. Abnormal redox reactions. Next, in a normal redox reaction, what actually happens? So here two different species are participating in the reaction. Here A is, that means one species is losing the electrons, the other species is gaining the electrons. That means two different species are exchanging the electrons. That means one is undergoing oxidation, the totally different species is undergoing reduction. Therefore, any reaction in which two different species exchange the electrons is called normal redox reaction. The best example for normal redox reaction is zinc. For zinc is reacting with the copper sulfate. Therefore, here zinc sulfate plus copper. In this reaction, zinc is losing its electrons. Hence, it has been converted into Zn2 plus. Since zinc is losing its electrons, therefore we can say zinc is undergoing oxidation. Next, here copper is gaining the electrons. See, Cu2 plus is getting converted into copper. Therefore, since copper is gaining the electrons, we can say copper is undergoing reduction. It is undergoing reduction. That means in this reaction, totally two different species are undergoing the oxidation and reduction. Next, abnormal redox reactions. So, what do you mean by abnormal redox reaction? First, let us observe the one example, simplest example. Chlorine is reacting with the sodium hydroxide and it produces the NaCl plus NaOCl plus H2O. In this reaction, before participation in the reaction, the oxidation state of the each chlorine is 0. Next here one chlorine atom is getting converted into NaOCl. The another chlorine atom is getting converted into NaCl. Here one chlorine atom which came here, it is exhibiting the oxidation state +1. The other chlorine which is coming here, it is exhibiting the -1. That means one chlorine is undergoing oxidation. The another chlorine is undergoing reduction. It is undergoing reduction. That means in this reaction, atoms of the same element are undergoing oxidation and reduction. Next, observe the another example. Then we will discuss about the what is meaning of abnormal redox reaction. SO2 plus H2S. Here S plus H2O. S plus wait. Here in this reaction, the oxidation state of the sulfur here is +4. The oxidation state of the sulfur here is +4. Here -2. Here oxidation state is 0. That means here this sulfur, it is changing its oxidation state from +4 to 0. +4 to 0 means it is gaining 4 electrons. Hence we can say it is undergoing reduction. Here in this sulfur, the sulfur, it is changing its oxidation state from -2 to 0. Therefore, it is losing its electrons. We can say it is undergoing oxidation. That means in this reaction, chlorine atoms are undergoing oxidation and reduction. Here sulfur atoms are undergoing oxidation and reduction. That means in both these reactions, the atoms of the same element are undergoing oxidation as well as reduction. Therefore, in any reaction, if the atoms of the same element undergo both oxidation and reduction, then they are called abnormal redox reactions. So therefore, both these reactions are the examples for abnormal redox reactions. But the difference between these two examples is, here before reaction the oxidation state of every chlorine is 0, but after the reaction the oxidation state of the chlorine has become +1 and -1. That means the oxidation state is changing from 0 to different oxidation states. But here before reaction the oxidation state of the sulfur atoms are different, +4 and -2, but after the reaction it has been converted into 0. That means here the difference between these two reactions is 0 oxidation state is getting converted into plus and minus, different oxidation states. Here different oxidation states are getting converted into 0. Therefore here in both the reactions same element is undergoing oxidation and reduction, but the difference is in this reaction the 0 oxidation state is getting converted into different oxidation states. Here different oxidation states are getting converted into 0 oxidation state. Therefore in any reaction if the 0 oxidation states converts into different oxidation states, then that is called disproportionation reaction. Disproportionation. This is disproportionation reaction, whereas if the different oxidation states convert into 0 oxidation state, that is called comproportionation. So abnormal redox reactions are two types, disproportionation and comproportionation. In the disproportionation as well as in comproportionation, same element participates in the exchange of electrons, but the difference is 0 oxidation states will be converted into different oxidation states. Different oxidation states will be converted into 0. If the 0 converts into different oxidation states, that is called disproportionation. If different oxidation states converts into 0, that is called comproportionation. Okay, sir.